a little bit of background on STEM outreach, and some resources that might be useful if you're wanting to do outreach, especially through the context I'm going to focus on is classroom outreach. We focus on pre-college, working in Pasadena with our local school district. So, proposal.
Could you just try to speak a little louder?
Sure. Thank you very much for doing that. Yes. So some resources. I'm going to go into some of the vernacular that's commonly employed. You've probably heard a lot about STEM, and then talk about two different types of education programs that you might want to get involved with or create on your own for outreach, formal science education programs and informal science education programs. So we have several of those programs here at Caltech, the ones that Suzanne mentioned I've been involved with, the Caltech Classroom Connection and the Summer Research Connection. And I'll mention some other programs and benefits, challenges, and models. They use different models that one might employ and then ways to evaluate those programs. Okay. So a little bit about some of the outreach experience that I have, and just to help think about different types of outreach experience, because when you're writing a proposal, you may want to contextualize your education experience in a program that you're designing. So there's lots of different forms of outreach. So many of you have probably already done some form of tutoring to friends or family. So I've worked in tutoring centers where you can do one-on-one tutoring, and also with nonprofit groups like Big Brothers Big Sisters. So in those formats, you can get one-on-one interaction. And then I've also worked in the classroom. So with the Caltech Classroom Connection, I was a volunteer in a classroom and then helped to co-direct it, and now it's developed into a program that I do as a job. I was also, while I was a grad student at Caltech, was involved in mentorship programs. So you may have been a SURF or MERF, some undergraduate research fellow. There's also the YES program, Young Engineering Science Scholars Program. So these are the programs where you get a mentorship experience where you're trying to mentor young scientists or high school students that are trying to learn more about science. Then I've also had experience at the college and high school level teaching, so at Caltech, and then also in a local charter high school. And that charter high school, because it's a charter and they can write their own charter, I can go and help on your science day. It's called Learning Works Charter School, and that serves a population of students that have not typically been successful in your traditional schools, and so we're really trying to help them graduate. So we have a lot of students that have had problems because maybe they had children, and so that's challenging, or they've been in gangs. So I'll talk a little bit about our education community too in Pasadena. And then I was also an interviewer for a type of programs called California Math Science Partnership Programs, or CAMPS. And those are programs between institutes of higher education, like us, which are called IHEs, and school districts, which are referred to as local education agencies. And so those are all throughout California, and so I've had a chance to go and interview those different partnerships, being evaluated, but basically interview those people to see how institutes of higher ed are working with school districts and trying to improve science. So I can tell you in all these different experiences, you can face very similar challenges, and so experiences in all these programs can help your success in future programs. And so consider some of this broad experience that many of you may have but not have thought about when you're writing an outreach proposal. Let's see here. So here's some educational resources that I wanted to share. Button that might go here with that. So, okay, so some that might be useful. The first one, there's a NSF user-friendly handbook for project evaluation. So when you're designing an outreach project, it's if you want to be more competitive, you want to talk about how you're going to evaluate your program. And this is a really good resource for discussion of all the different ways to evaluate a program using things like surveys or interviews or focus groups and the merits of all those different types of evaluations. Greatschools.org is another user-friendly source to go and compare public schools and to look at schools, public and private, in all sorts of areas. So you can look at our local area. The California State Board of Education standards and frameworks. So this website here, CDE, the California Department of Education, you can see the content standards. The content standards were adopted for science back in 1998. And you can also see the Common Core standards, which have just recently been adopted. And those have been recently adopted for English language arts, which people refer to as ELA, and also math, but not science. So it's kind of an exciting time right now because there's some new frameworks that have been proposed, and so we know we're going to have more emphasis on science. These are also good to be aware of because when you're writing a proposal, if you want it to seem realistic, you need to appreciate the challenges that teachers have to face in terms of the pressures that they have to get across certain standards and stay on pacing types. So these can be helpful in figuring out where your research is going to connect. And then there's also the California Department of Education has this resource called DataQuest, where you can actually pull up statistics on demographics for your school district and compare it to the Los Angeles county level and the state level. There's some other simulations that I've found useful in working with high schools. Maybe you've heard of those, at University of Colorado. And then these organizations are valuable for us here in California. The National Science Teachers Association, the California Science Teachers Association. And they recently just had a conference in Pasadena. It was hosted at the Pasadena Convention Center. And it's a great, it doesn't cost a lot to join these organizations, and you can get journals, which can really help you appreciate the level to aim for if you're going to be working with an elementary, middle, high school classroom and see really creative ideas that people are doing. Here's an example of what the data quest looks like. So if you are writing a proposal, and a lot of proposals target or they're interested in groups that are also aware of reaching out to groups that are underrepresented in science and engineering. And so if you go here, you can pull up PUSD. So these numbers are too small for you to see. Sorry, I can share some of them with you. But basically, you would click all the little boxes that you want to see, that you want them to sort of present in this Excel, and then it spits it right out. And you see how it compares to LA and overall in the state. So here, these are different demographics: African American, Asian, Hispanic, Latino. And then there's also English learners, so English language learners, or ELL, is also something to be aware of when you're working in classrooms, because in California or in many different states, you have students that this isn't their native language, and so you have to really think about that if you want to get as much as you can across in a science lecture, because language and vocabulary can be a barrier. And there's also free or reduced price meals, and that's an indicator of a low socioeconomic status. So, so you can see that in Pasadena, we have more than 77% of our student body are groups that are underrepresented in science, and more than 68% are on free and reduced lunch. So Pasadena also has one of the highest per capita enrollments in private schools. So that also throws another interesting sort of factor into the mix. So even with some of these other science, these IHELE partnership programs that I got to visit in California, in rural California, they don't have these high, this high density of and so you'll have students that are working, out in these rural areas that, lower socioeconomic status, sitting next to other students that own the land and own these ranches and stuff, and so you get some interaction there in the classroom. But in Pasadena, it's something that we also have a little bit less of, kind of that a little bit of a brain drain from the students that are in private schools. So that being said, there's so many great things happening in our public schools and fantastic teachers and amazing students, and so if you really want to make a change, Pasadena is a great place to do that. So this says STEM or STEAM. So in most of these outreach proposals, you see this acronym STEM: science, technology, engineering, and mathematics. And there's been this also recent sort of trend to include an A in there for art. And one thing I was just reading recently on a science blog is sort of 2 reasons why including art is something you might want to do. So the first one says, art is a different way of perceiving and knowing and dealing with the world as a means to expand the toolbox of science and engineering. And the second claim for including art is that based on the limitations of scientific research and of engineering design, which some see as lacking creativity and fun. Also, in our art classrooms, we have programs that are becoming more sophisticated and technical, and so students would benefit from interacting with scientists and learning more science. They have to follow procedures and protocols, and they have to be reminded that those are similar things that experimental scientists do, and that those are skills that they're learning to translate. And in those classrooms, you have students that like science, that also like art, and then you have students that think they dislike science because they've had bad experience with science, and so they're choosing arts through science. So I think it's also worth trying to make those connections so that you can reach out to more students. And there's also the benefits that we have by working with artists. So one of our CCC volunteers last year had this article on the cover of Nature Physics, and he collaborated with an artist to find different ways to represent this data, visual ways to represent it that would sort of look exciting. And so there's a lot of worthwhile reasons why these sorts of collaborations would be beneficial. And I guess this speaks to like a general trend of trying to include science in really like all the classrooms. I mean, there's opportunities to include it in history classes too, history of science. And we also have in Pasadena academies, and so we have academies at the high school level that focus on different sorts of programs, and one of those programs is a culinary program. So, for example, you could incorporate food science. So, I would think about incorporating science into not just your traditional science classrooms, because I think in general students aren't getting enough of science, especially at the middle school and elementary level. So the more we can incorporate it in different subjects, the better. So informal science education there are entire programs devoted to this, and with the NSF they have ISC initiatives. And we wanted to also get involved in informal science education programs because we wanted to provide more opportunities for students to experience science. So this is one definition of informal science learning, but it's basically science that's taking place outside of the traditional classroom setting. So here are some of the programs that I'll go into detail. But with these programs, for example, teacher partnership program, we have formal science education that's happening inside the classrooms, but then we try to augment that with field trips and other activities, which would be informal science education to increase the exposure to science. So science fairs can be informal science, but they can start in the classroom, and so they can be both. So the Caltech Classroom Connection was initially started by a grad student at Caltech, and there were about 6 partnerships that they formed between Most of them made it into the classroom at least once. And so we've been, over the years, growing the program. The program initially was grad student run, and what we did was invite a senior volunteer to move up into the leadership role while one person graduated so that we could sustain the program. So one thing to think about when you're designing the program is sustainability, and that's something that the NSF emphasizes. How are you going to make it sustainable? How are you going to develop a cadre of teacher leaders that can maintain the program after the funding runs out? And so what we've tried to do with the increased funding is to grow the program to be a bit more of an umbrella program that can also help other outreach efforts on campus that want to partner with the local schools. So you can see our mission statement is pretty broad, and it's been that way for almost 5 years. So that we could do that, and that way we can encourage creativity in asking the scientists to sort of do their own special project. So here are some of the goals to increase enthusiasm, interest in science. We want to try to help students appreciate why they should care about science, where it's in their daily lives, and how to do science. So many of the students, especially again at the middle and elementary school level, but even at the high school level, their idea of how they follow science is still very much a scientific method is this one path that we follow. And it's not this broader view of how we can design experiments and do lots of experiments and collect data and understand the world better. So we're trying to improve that while and also to create more authentic research experiences for students. So try to find out better ways to teach science by collaborating with the teachers, coming up with better ways to teach science so that the students feel like they're actually doing something sciencey and scientific, and they're researching things in their classroom. So here are some benefits and practical experiences that I just listed out. So for one, grants require outreach now, many of them do. So you have to take it seriously, and many people want to do this because it's fun, right? It's a refreshing experience, and it's so rewarding when you leave the classroom. The students always want you to come back, even when they don't understand what you're saying. They still appreciate seeing something different and seeing a real scientist's face. At the younger grades, you're almost given rock star celebrity sort of treatment when you come back in the classroom. They get so excited. And so if you're, if it's something you want to do, then you can get it into your grants. I think many of your professors will be happy because it'll make it more competitive. So I collaborate with about a dozen different professors who ask me to help them craft their outreach so that they can plug into this model. And that's one thing that I heard from an American Physical Society conference from early award winners who did outreach and were giving advice. They said, try to find sort of existing programs and models and see if you can plug into them and do something creative so that you're not trying to reinvent the entire wheel from scratch. You get great experience teaching because it's a very forgiving audience. Teachers know lots about pedagogy. Even, it comes natural to them because they've been doing it so long. But when you can actually get some discussions going to get feedback, you can learn a lot about your own teaching style, how to improve it. If you're going to go into, if you want to become a faculty, then you have to give science talks, and so practicing presenting in front of groups of people helps. If you want to become a faculty, you're going to do interdisciplinary research. That's another area where former CCC volunteers have said they felt programs really benefited them. It's when they have to talk to their physicists, they have to talk to biologists, and sort of bringing them from assuming sort of no background to their level of research is something that they said was easier after participating in these sorts of programs. teaching college experience. So one of our former volunteers is at a teaching college in Manhattan. Undergraduate level, and she said that when she went for her interviews, she talked about her Caltech teaching experience, and they didn't seem that interested. When she mentioned her experience working with a third grade classroom, they were especially interested, and they knew Caltech, and so they were saying, said to her something like, oh, I think that's going to be more along the type of experience you need for our students. Like, I don't know if you were expecting Caltech caliber students here. I don't want you to be disappointed. So they thought that was valuable. So she thought that was actually really more. Also, one of our former co-directors works for an engineering consulting firm, and she emphasized to me that when she would talk to her students about doing the scientific method, and these are some of the things where you can help them most because it comes really natural for all of you to discuss this sort of scientific method and figure out how to design an experiment, how to do an investigation once you have a scientific question. And that's where I see a need and desire from teachers to get more experience. So, this former co-director said that it was kind of like it was like an epiphany she had. She's like, yeah, I was sitting here like explaining to the third graders, how they should follow doing the science investigation. It was exactly almost the same thing that my advisor had been telling me from like earlier when I was giving a group meeting or something. And so, it's really like reinforces these things that you're doing here anyway. And it's also kind of reassuring you remember how much you know because you go into these fields, into these classrooms, and you remember, oh yeah, you're experts in the fields that you're in, and you've learned a lot, and you can come up with more models and examples and applications to communicate, because that's what will really engage students. So a little bit more about the teacher partnership program in particular. So that's we create partnerships between you, the scientist, and the local science teacher, and we have a pairing meeting. And so the pairing meeting is where we sit down in the classroom with you and the teacher and talk about all the different things going on in that teacher's life and classroom and in your life and your research, and how to collaborate with the classroom over the course of an entire particular classroom. And so you get the ability to develop a relationship with those students because you can see them, and it takes students a while to kind of open up and answer your questions, and especially at the older and so you have an extended period of time to also try to improve the science curriculum by collaborating with the teachers. So some advice that I can give you on doing that, maybe you want to develop your own program and develop a particular lesson or module for a proposal, is teachers will emphasize, when we had an elementary teacher, said, take your lesson that you're going to teach and then cut it in half, cut it in half, and then cut it in half, cut it in half again. You should go on it for a little while. And it's really true that we probably come so easy to us now. We have all this scaffolding to reference when we're thinking about science, all these things we can relate it to. We probably want to communicate way more than we can to the students, and so trying to cut what you want to teach down a few times is a good tip to think about once you've sort of got your lesson. Thinking about language is also important because I mentioned the language learners, and vocabulary is a big part of the curriculum, language arts, and so if you can help work with schools to use science notebooks and incorporate language arts, then it will probably be more well received, because these are things teachers feel pressured to also perform on, because those are the things that are being tested. I would also strongly suggest to model the norms or the behavior for students. So I take very little for granted in terms of students' understanding of science content or science procedure. So when I'm working school and we're collecting data, they'll always just say the numbers. So for the first few times, I'll say 10 what? 10 Gauss. Okay, 10 Gauss. And next time they have to take several numbers. So I'll ask them, and I'll probably have to remind them again. And after the third or fourth time, then they're saying, one thing I've noticed, and this happens with students that are in high school, but they have a hard time using a calculator. This might be the first science lab they've ever done. Some of them have had no good science experiences. Is that I'll see them start to smile, like they realize, oh, I know what I'm supposed to do here. I'm supposed to say the unit, and they kind of seems like they have a sense of pride, like, oh yeah, it's 10 meters, and they still confuse the units. But I think it's a really great thing to model that, the language, but then also the procedures. High school students will say, you'll tell us the procedure, and then we go to the back and we kind of look at our data sheet. We don't know what to do. It'd be better if you kind of did it with us. So, doing things with the students, but then maybe not getting too carried away where it's like a completely directed instruction where we're like, no, split the, everybody right now, okay, now add beaker A to B, right? I've seen that kind of go to extreme cases too. So, and also, like I mentioned before, keeping in mind the California State core standards that teachers have to teach their local textbooks. In Pasadena, we have in the middle school textbooks that come with kits that let us do investigations, and so teachers do those investigations and use those worksheets, and we'll look at them and find all sorts of errors, and just ways to improve it and make a better flow. And I would really emphasize trying to include your lesson, cut it down half enough so that by the end you have time to reflect and compare student data. So that's where I've seen tremendous sort of aha moments with students is, one example, actually one of the teachers who's here tonight, in her class we were doing e-transfer and put all the data on the board about how fast the wax was melting in this piece of metal where heat was being transferred from a candle. And in one case they were using a candle, in one case they were using a lighter. And the numbers were pretty drastically different. And when students see their own data, they can't make, it's hard for them to see trends, but when they can see their friends' data and everyone's data sort of clustered together, then they can get the general idea, right? Are these numbers close together or far apart? How many people think they're far apart, right? And then you see that generally you get it. And in this case, there were numbers that were significantly different, and they could see that, and I asked them, why is that? And there was some speculation, maybe it's the heat source. And I thought, no, it's not the heat source, because these are pretty similar PTUs are putting out. And it turned out it was the material, right? They were two different steel pipes, but the students were able to come to that realization themselves with asking the right questions. And in another recent example where we did we measured temperature of water as it was warming up with hot water, or when it was cooling down with cold water or ice. And so in one case we have a state of change, a phase that is changing state from ice to liquid. And so you see large changes in temperature, or small changes in temperature. You see that the temperature is kind of halfway in between where we think the two temperatures to kind of come to equilibrium, versus if we were changing the state of ice and it caused a lot of energy, and the middle temperature wasn't in the middle, the final temperature wasn't in the middle, the final temperature was lower because we had to use all this energy to convert the ice to liquid. And it was something that students were not able to see before, but just by kind of redesigning the lesson and putting the data, for all the students to see, they could see, yeah, these are halfway between, these are kind of in the middle, they're kind of not. So general ideas. So I think this is the one thing that it gets missed a lot. It's really hard because it takes so much. You have a classroom of 40 students and you're trying to get a lesson, but you don't make it to the end to actually showing the data and students to try to come away with something from the data. So it's another thing that I would suggest. So in these programs, some classroom management tips and strategies is I would suggest talking to veteran teachers, because sometimes they do things, they've been doing them for so long that they come second nature, and so trying to be metacognizant of them and asking them for some critical feedback. Because appreciate too, when you come in, many teachers might feel nervous because you're an expert. On the other hand, they you should appreciate that they're experts in this other field of pedagogy, teaching, but they may not want to be critical because you're doing a noble thing and helping out. So so I think sometimes you have to draw it out to get some critical some feedback. But I'd encourage you to do that. Cooperative grouping and peer-to-peer teaching. So in science, we work in groups, and that's one thing we've realized we can get across to students in these programs is their appreciation that scientists work in groups and that they help each other out. And so designing lessons so that you have students working together, changing those groups throughout the year, giving a student in one group the answer, but then telling the student that they have to explain it to the other students because at the end, someone will be sharing with the classroom. I think are great things to work into the lessons or the type of outreach. And so when you're thinking about, when you're talking about lesson flow, you can think about how are you going to introduce your lesson. I think it's a good idea to start with a phenomena or a question, some sort of motivational thing, like a demo, and to assess the audience and see how much they know. So I would suggest one way to get started doing that if you want to try and engage the classroom is to ask questions and give some thought to those open-ended questions so that the questions are questions that are easy for students to share something so that they're willing to share. It's not necessarily right or wrong. It's maybe their experiences. And then to also use hand raising as a way to get students to interact and to start to kind of loosen up and feel like they can engage you. So so for example, let's see, raise your hand if you have brothers and sisters that are in science. Okay. And raise your hand if you don't have brothers or sisters in science. Okay. All right, great. And then of the people that didn't raise their hands, can I have a volunteer who is willing to? Okay, so I'll stop right there. That's I didn't use the best example there, but this is like a simple strategy you can use to get students to engage. So you can ask students if they agree with the concept, and then if they don't agree with the concept. And then you can also, particularly, thumbs up, thumbs down, things like that. And you can also look for students that are engaging or not. So, and I've found that in general, students don't seem to, they don't get upset with me if I call on them, if I do it in a supportive way, if I'm not trying to, single them out. So I've actually had cases where students have sort of acted out in class, and I've asked them later about why they're acting out and how the lesson could have been more or engaging for them. And they said, well, they could have asked me a question. And I pointed out, well, we were asking questions, but some students that don't engage in science classrooms may not perceive sort of open-ended questions from an audience as directed towards them. And this person didn't have any problem with me singling them out and asking them a specific question. And if they struggle, you can ask, so can anyone help out your classmate here? Any other suggestions? But this way, students, it's an easy way for them to participate. It'll help sort of everyone relax. And it can make the people that don't participate aware that by not participating, you may also be sort of participating. So I identify volunteers now when I go into classrooms, and I try to do that early. So here's some ideas here too for making sort of engaging lessons. I'll look for students that seem like they have too much energy and that they might be distracting, and call on them to come up and hold something. That I might
for the whole lesson.
For the whole lesson, yeah. Expand it. I make it smaller. Keep doing that. So they seem like they want to contribute to the class. They just don't know how to use their energy. I a lot of students that are having problems in class, or might really love science. I mean, you want to pick them to come up and do demonstrations, but you don't want anyone to get made fun of. And once you have students coming up, then other students realize that oh, this is something that I might get to do. Exciting. So you'll get some classroom compliance sort of all over the class. And I would encourage to involve students in the design of the lesson and evaluation. So they talk about the stakeholders, everyone who's a partner in the program that you're designing. So as early as you can, get the students involved and ask them, why, what they're interested in, how we should evaluate them. And here's some examples of how you can do some simple evaluation. So here's some science performances that we do as part of the program with mostly undergraduates, but we also have some grad students involved. Anyone's welcome. But this was something that we developed so that we could also fit with undergraduate schedules. And so we started doing these science demonstrations, and we collected data, like just told students to write down things that they remembered, or they liked, or they enjoyed, or ways we could do it better. And don't have to put your name, it's not right or wrong. And so this was a really great way when we were first developing the program to figure out what we could, what are some of the things that we might be able to affect. So one of the ones I put in red was one that we saw come up a lot, that students from just a 1-hour presentation, they could really appreciate that science isn't, when you do bad on a science test, that's bad, right? But if your experiment fails, that's not necessarily bad. They thought that was always bad. They didn't know if they were surprised to know that when our experiments fail, we'll still get paid. We don't get paid by the experiment. And that you get paid to go to grad school. And, so that's so far off. They don't know, that might help many of them realize, okay, there's opportunities in science, you can get paid. And it also helps you realize how things can also be absorbed, right? Like one student said, oh, I learned that medicine takes 15 years to make. Okay, well, we realized we need to kind of be careful how we sort of present these things. One of the students was talking about how drugs go through trials. And,
what grades are these?
What's that?
Grades.
So these are mostly 8th grade middle schoolers. They want to know about college life. They wanted to know what we would do if we weren't scientists. And I tried to say I would do biology instead of physics, and they were like, no, you can't choose a science field. What would you do if you couldn't be science? And okay, I'd be a rock star or something. Someone said they would be a baseball player. But they really wanted to see that we had like another side to ourselves. And going back to this emphasis of trying to get students to help them do research, real research experiences, this is something that we have been trying to develop. So new lessons on research, and this is one way we're getting started with, this is one of the teachers who's here tonight, one of her classrooms, asking students to just come up with projects that they want to investigate, to see if we can help them group them and develop their own projects, and then maybe that would lead to a science fair, because science fairs are a place where you can get these sorts of researching experiences, but they seem they can also seem like one more thing to do in the local public schools, and so finding another way to incorporate it into the classroom, I think, is worthwhile. I didn't have time to go into this. This is summer programs. Summer programs are another form of informal science education. We have the Summer Research Connection, where teachers work together with either sophomores or juniors in high school, and they do research projects at Caltech. And we have weekly seminars, and this is like a full-time thing that we do. So this would be like a major project if you wanted to design a summer research experience for students. Or, again, you can leverage existing programs. So programs like ours, we're always looking for mentors. So you can plug into our program, and we offer support for materials and things like that. And here's one other example I wanted to share. This John Muir Solar Boat Club. So here's a reflection that one of the students wrote. These sorts of experiences, again, they give more opportunities for students to do science, a safe place to do science. And many students are looking for something to do after school. good alternative to video games. There's also important scientific research in video games too. I don't mean to bash video games. Yeah, in general, we try to collect some sort of data though, and collect reflections from our students to see how we can improve programs. And we see that programs like this are also very beneficial. These students from last year got to meet the mayor, the school board. They had a really exciting time. And several of them went on to declare environmental science and engineering as a major. I guess I'm not getting too much into the bias. With these programs, you sort of select for sometimes students that are interested in science. But still, these sorts of programs tend to get them more excited. And another thing that we do, which I didn't have time to go into, is professional development opportunities. But we have a teacher here tonight that also participated in those. So I wanted to bring some teachers so that if you also had specific questions, you could hear it from the teachers. I've sort of mentioned evaluation and reporting. I would really recommend that user-friendly guide from the NSF if you want to learn sort of background. There's things they test, common ones like formative and summative assessment, which there's this clever way to think of it. You hear people talk about this a lot. So formative assessment comes at the end of a program, so it'd be like the cook tastes the soup. Or sorry, it informs the assessment, so it happens throughout. So it'd be like the cook tasting the soup and improving. Whereas summative assessment happens at the end, so it'd be like the guest tastes the soup. But you can also report on metrics in terms of the people, number of classroom hours, and student hours. These are also number of metrics that people use for reporting. And consider a section devoted to how you will modify the design of your program based on evaluation. Even if it's not a complete randomized controlled trial, there's still lots that you can learn from these programs. And so you have to kind of appreciate that they're going to be experimental or quasi-experimental. And have an assortment. So we do an assortment of surveys, interviews, observations. And this is one type of survey that we're currently focusing on. So this comes from a survey designed by Grinnell College called the CURE survey, the Classroom Undergraduate Research Experience Survey. And we also have a similar one for summer programs. And so we've modified it because it's for undergrads, so we can give it to our high school students, but you can see what they have is a scale from 1 to 5, and we can see sort of their self-purported learning gains in these different categories. So from greatest to least, they find that they have a lot of learning gains from working independently and in small groups. Let's see, what else? Oh, and then least is reading from textbook, which sometimes they get a lot of. So that's a current survey that we're focusing on right now with our teacher partnership program and with our summer program. So this was a survey that was developed, and we just started this last year. So this is fresh data, and we have, we can go more to that. So that's it. I want to give time for the teachers to talk. So we have actually, so can you guys, let's see, so maybe I'll call you up and you can just say a little bit about you. So Armin, if you want to come up. So Armin is a middle school teacher. He's been with the program for several years. A great CCC fellow, and also did the summer professional development. Marlene has also been collaborating with us in the lesson study model, where we try to take a lesson and see how we can redesign the lesson, reteach it, and improve it. And then Ann Anderson and Chris Anderson. I'll let Ian Anderson sit in his chair up there. They've been involved in the classroom, in the partnership program, and also in summer programs. So, yeah. What's that? And so these are all Pasadena Unified School Districts. So since our funding, the funding directives we have are actually primarily focused on PUSD. So these are our PUSD partners. So now I will shoot it over you guys, and if you want to ask questions of me or the teachers, the outreach programs, it comes with both. Yeah, do you wanna?
Came into the district about 20 years ago, and at that time there was a project that was called SEED, and there was a couple of, there was a teacher at Pasadena Unified that was appalled that there was no really science experiment kind of, there was no experimentation going on, very little. And she was actually an elementary teacher, and she knew some professors at Caltech. I think one of them was Jerry Pine, I think he's still here. And the other one was, anyways, so they developed a series of kits for different grade levels. This was primarily kindergarten and then eventually went up to 8th grade. So that was adopted at some point as a Pasadena Unified program. Teachers came in, like I came in, on campus and worked with various scientists on a kit, say it was on magnets and motors or the human body and so on. I thought the problem with that was that there was no, at the same time, academic component to it. It was like experiment. There was no text. But anyway, that being aside, since then the district's adopted a book called CPO, and that book has investigations, as James mentioned. So it actually has materials, and the materials can't be used in a series of experiments. I don't think they really last for the whole year. At Sierra Madre School, we use that as a backbone, but we also develop our own experiments. And how do we develop them? We just, we read here or there, and that'll work. We think that'll work. If it works, we do it again the following year. If it doesn't, we do something else. And it's supposedly related to the curriculum, 7th grade life science, but I do things that if I think are something that would get students interested in science, I just do it. Regardless if it's, I make it tangentially related, if I make a way of finding it being related. So,
Which grade are you talking about?
7th grade, I do 7th grade introduction to biology, life science, whatever you want to call it.
I teach 8th grade physical science, which is chemistry and physics, kind of thrown together, a little bit of astronomy. I've had Caltech connection several times there. I've only taught for 8 years. I was a microbiologist. Some of the lessons were from my curriculum, and then once I've established some kind of relationship with someone, I've said, this is what we're doing next week. I really don't like what we're supposed to be doing. What do you think? And sometimes we brainstorm and come up with some new thing to do. Right now, James and I are working with the curriculum that we have because they've supported us with supplies to try to make them work better, or if not, throw it out and give people other. So it goes both ways.
Could you say a little bit more for those of us who aren't familiar? Who's them and who are you working with? And what
Okay,
kind of
the
things do
Cal
they come up
Connection
with?
can provide people to come in and help in our classrooms.
So like students?
Students, I guess they're grad students, and they come in, and you set up a time that they're available, and they would come in. I'll say, I'm doing a lab next Tuesday. They show up, and at one time it was like a partnership. There's 2 guys that showed up, and I was teaching 7th and 8th, so it just depended on what we were doing, and they would come in and run with it. And then it really helps because then the kids, for somehow they're a little bit more open in talking to the students and asking questions, and it really created a different atmosphere in the classroom. It was really nice, and it helped me too. I was concerned when I first went into the field. There's most of the people teaching middle school science had no experience working as a scientist, so having those people come in is really good thing to see it in a different perspective. And yeah, I've had, and then when James comes in, we've talked and done a lot beforehand, before we've done the lab, and then we do it together. But with them, they would just like, okay, I'll show up, and they just go with it. Whatever I was running, they would help me do it. We made oobleck ones, just different things you do with kids, right?
You want to say something?
Oh, yeah. Well, I think I may be coming from a different perspective, saying I was not a science teacher. I was actually a math teacher. I had 2 different grad students come through. One had to go and graduate and get this fat job in New York, leaving the kids behind, but whatever, I got over it. And for the first graduate student that I had, what we did was we met, and I just gave him a list of the topics that I heads up that I would like him to do the demonstration more maybe a week after I finish the unit, so then the kids could have better background on it instead of doing it prior and then maybe a lot of information going over his head. With my second graduate student that came through and helped out in my classroom, I ended up with this Algebra 1 class that was just really strong. I had 3 Algebra 1 classes throughout the day, but this one class would do the material literally almost twice as fast as the rest. And I'm like, okay, I gotta get extra stuff for him. So we sat down together and collaborated on this year-long unit that was just outside, above and beyond what I had to teach in the classroom, to where they could apply a lot of the information that they were learning in the classroom. And we wrote some grants. Caltech helped me out with a few things on top of that, and they just created this 3D Lego-based project that flew over really well, and kids were stoked about it, and I was happy with it, and Caltech was happy with it. So I don't know. In most cases, I think as teachers we're flexible. With the pre-calculus class, I did have to worry about standards, making sure that the things that we brought into the classroom were standard-based. With the Algebra 1 classroom, because they were already so strong with the standards, we had the freedom to go outside of it.
Since it seems to me, it's the first time I'm coming to this program, but it seems to me that the idea is to make teachers more effective in their classrooms. I would like you to share, did you feel or did you find out that Caltech is helping you to become more effective teachers in science, and how are you measuring that?
So, whoever wants to add, yeah, no, I was just thinking yeah.
My background is actually in elementary education. I taught 3rd grade all the way to 5th grade, and then I taught 6th grade. And so transitioning from elementary school to middle school, even the 6th grade curriculum on an elementary campus is very, very different, because you're in elementary school, you're responsible for all of the curriculum, whereas when you're in 6th grade on a middle school campus, you focus on two subjects. And since my background was not in science, I felt that I could understand science, but I don't think I was equipped to teach science on a middle school or even a secondary school level. And so I felt that having a scientist in the room to help clarify some of my misconceptions or my understandings of material was very useful, and they could actually elaborate on a lot more things than I could, and then put it into a more real-life applicable setting for my students, because they either have experienced it many, many times over versus my narrow understanding of a certain subject. So I think that in that sense, it increased my own content knowledge, because reading it from a book is different than seeing it or someone explaining it to you. And so having that one-on-one is kind of like having your own private tutor explain it to you, and you're like, oh, I get it. I never thought about it that way. So it's the collaboration that has really enriched my own understanding of teaching, my own understanding of just the knowledge in itself.
I'm not sure about your experience, but I know one of the other, Anne also did our summer research connection program, and one of our elementary teachers emphasized that in that sort of program, doing the research themselves sort of translated into the classroom, doing science and sort of helping confidence in science.
Yeah, because it's funny, because I remember one of the SRC coordinators, Sherry, was using the word assays, and I was just like, what is that? And so I had to listen to it a couple of times during a presentation, and I was watching CSI, and lo and behold, the word assays comes on the television. I was like, oh, I know what that is, and it was just like an awareness. All of a sudden, it's like you see it completely different. It's like you just learned a brand new language, and you finally understand all the things that were being said. I mean, before you kind of understood it, kind of in this foggy mist, and then once you've actually experienced the research and been through it, it kind of opens your eyes, and you're like, oh, wow, I didn't even see it like that. So it was a completely different perspective. Teaching the scientific method is completely different than actually experiencing it, because sometimes we just get so caught up in like these are the steps, whereas it's not. Those are not just the steps. It's a very circular, never-ending process. It's just that in school we teach it like it's a locked step. It's not a locked step in real life. That sometimes things happen and things change, and and given a certain amount of time, the process can either end or it can continue for years. And so I think that was really interesting to bring back to my classroom, because now I can truly say, well, when I did X, I expected Y, but that never occurred. I got something completely unexpected, and we had to go back and change course. And so be able to say that was very powerful.
And that perspective really changes the way you present the material to the kid. And if we could get them to have that same aha moment that she just had, is really what we're trying to achieve. That they're connecting all this stuff that they're seeing, all these words that we've thrown in, to actually, and then bringing people who have all this energy and enthusiasm for their fields into the classroom makes the kids look at it in a different way too.
And now you're very lucky to have Caltech right here around the corner.
And the enthusiasm was one of the things that at the beginning I had to tell my volunteers, like, yeah, I understand, and that's a great ideal, but unless you want to be here for about 2 weeks, the kids aren't going to get it. So there was a lot of back and forth collaboration. So we got to the point where 2 weeks before he came, he would shoot me an email, this is what I want to do, and I was like, okay, that'll probably take you about 4 days to teach. So which part is important to you? And there was a lot of back and forth. I love the fact that he could bring in information that I wouldn't say was beyond me, but it was unique. It wasn't in the sense of what you would see in the textbook or even like some high school research-based stuff. It was really on a high level, and then we just worked together to make sure we could bring it down to the level to where the kids can understand it.
Yeah, I think the people that come in the classroom are not expected to make you a better teacher. I think that's something that you mentioned. You've already learned through your own teacher education and your on-site practice, but having the connection with an institute like Caltech, you get to have access to things that you normally wouldn't. And so the graduate students that come in, here's an audience, she does her research on fruit flies, so that she brought in an offshoot of one of her experiments, and we got to work with that, which we never would have been able to do that. Another graduate student did brain research, brought in brains, and she led some dissection of brains. So I think that it expands your horizons. I also was a science major, so I want to, you're asked to teach science, so you want to do it in the best way you can. I have a graduate degree, but it's not in science, so I'm not going to go back and do another graduate degree. So you do a certain amount of work on your own, but then you learn as you go through graduate school that there's ways to access knowledge that are way quicker than going through taking classes. So you start to do that, and this program provides that vehicle.
Okay, so it's been about an hour, so we're going to go ahead and wrap up, and if many more people have any questions, feel free to come down and ask them directly to our panel or to our speaker. And so let's just thank our speaker and then everyone can